China's Mars Orbiter just captured 3I Atlas. Older than our solar system, something ancient is moving through our solar system. A relic older than the sun itself. First detected near Mars, its structure defies physics, its origin predates creation. What if this isn't just a comet, but a messenger from the dawn of time, carrying secrets the universe never meant for us to see? A signal from Mars orbit began as a flicker, a subtle irregularity buried deep in the steady stream of telemetry flowing back from China's Tianwen-1 Mars Orbiter. To most systems, it would have looked like noise, a meaningless blip in the cosmic background. But to the engineers monitoring the orbiter's high-gain sensors, it was something else entirely, a pulse that repeated, faint yet deliberate, as if the void itself had whispered. At first, analysts assumed a sensor fault. Mars, after all, is an unforgiving environment for precision instruments. Dust storms, radiation bursts, and orbital interference often create false readings. But as Tianwen-1 continued its sweep, the pulse reappeared, synchronized across multiple instruments. More intriguingly, its spectral signature didn't match any known satellite transmission or natural radio echo. When the team cross-checked with the ground-based deep space network, the anomaly persisted. Whatever it wasn't coming from Mars or Earth. By the third pass, the orbiter's cameras locked onto a slow-moving object beyond Phobos's orbit. It reflected light in unusual wavelengths, shimmering not like rock or ice, but something older, worn smooth by uncountable ages drifting through interstellar space. Within hours, preliminary trajectory models stunned mission control. The object was not bound to the sun. Its hyperbolic path indicated a visitor from beyond the solar system, the third ever. Detected after Oumuamua and Borisov inside the control center in Beijing, tension grew thick. The signal wasn't just data, it was history unfolding in real time. Teams began running orbital dynamic simulations, cross-referencing old sky surveys and comparing energy readings. Every calculation pointed to the same unthinkable conclusion: this was 3I Atlas, a cosmic wanderer once lost to the void, now captured fleetingly by the watchful eyes of humanity's emissary around Mars. Whispers rippled through scientific channels. How could an interstellar object drift so close to the red planet? Was this chance, or something orchestrated by forces far beyond comprehension? As Tianwen-1 prepared for a full-spectrum scan, the world's astronomers held their breath. For the first time in recorded history, an alien object from another star system wasn't just passing through our neighborhood, it was being observed from another world. And in that moment, Mars became more than a planet. It became a window into the ancient, uncharted dark between the stars. Unveiling 3I Atlas, when Tianwen-1's imaging suite finally stabilized its lens on the object, the data it sent back didn't resemble anything the mission team had ever seen. Against the black sea of Mars orbit, 3I Atlas shimmered like a fragment of frozen lightning, geometric yet fluid, its surface glinting with a metallic sheen that seemed to shift depending on the angle of observation. The first high-resolution images stunned the scientific community. What should have been a tumbling mass of rock instead revealed symmetry. Sharp edges, curved indentations, and mirrored planes etched across its surface. Some panels appeared fractured, others covered with what looked like pitted scars, as if the object had endured eons of collisions and radiation. But beneath the erosion, there was pattern. Not random geology, but the faint suggestion of design. Spectroscopic readings deepened the mystery. The material composition defied classification. Elements familiar to Earth's periodic table were present, but arranged in impossible ratios, suggesting processes far beyond known chemistry. The object reflected light in polarized bands, similar to engineered alloys used in high-frequency optics, yet its albedo fluctuated with precision, almost as if it was responding to the instrument scanning it. Within hours, data began circulating through encrypted channels. NASA, ESA, and JAXA quietly requested access to the imagery, while China's National Space Administration imposed a brief communication blackout, citing anomalous readings under review. But by then, a few leaked frames had already reached independent analysts, sparking fevered speculation. Was this a fragment of an ancient probe? A remnant of pre-solar debris? Or, as one unnamed astrophysicist put it, a message carved into motion? Further analysis revealed that the reflective patterns changed rhythmically, not chaotically, but in intervals matching a mathematical sequence. Some experts dismissed it as coincidence, but others saw something more deliberate, a possible encoded signal, embedded in the way 3I Atlas scattered sunlight. As the story broke across global media, humanity found itself staring at the first truly alien artifact ever recorded in detail. The line between science and belief blurred overnight. Was 3I Atlas a relic of an ancient civilization? A natural crystal shaped by cosmic entropy? Or was it something else? A vessel, dormant and waiting, drifting silently in the Martian sky. Whatever it was, 3I Atlas had rewritten the boundary between curiosity and contact. Older than the sun, the first isotope readings from 3I Atlas left mission scientists speechless. Every known celestial body, from asteroids to comets, carries a distinct chemical fingerprint, one that ties it to a specific era of cosmic formation. But 3I Atlas did not fit any epoch within our solar system's timeline. Its isotopic ratios, particularly in oxygen and carbon signatures, were so ancient that they predated the birth of the sun itself. Spectroscopic data revealed a staggering truth. The object was composed of matter forged in the aftermath of first-generation stars, those colossal furnaces that burned briefly and died in violent supernovae more than 7 billion years ago. In other words, 3I Atlas was older than the solar system by at least 2 billion years, a traveler from a forgotten cosmic era. The material composition was equally confounding. Embedded within its crust were traces of exotic isotopes, beryllium-10, aluminum-26, and heavy oxygen variants, arranged in proportions that could only exist in the cooling remnants of primordial nebulae. No known process in our local stellar nursery could have produced them. To astrophysicists, it was as if 3I Atlas had carried a memory of the universe's infancy, locked within its molecular lattice. Debates erupted across research centers. Was this relic the fragment of an ancient planetary system long destroyed? Or perhaps the remains of a civilization whose star had died before our sun had even formed? Some suggested it was a seed of matter, cast adrift through interstellar space, a messenger from a pre-solar age. Yet one detail unsettled everyone: its stability. Most primordial fragments this old would have eroded, shattered, or been pulled apart by gravitational forces eons ago. But 3I Atlas remained eerily intact, as if protected by a composition or technology unknown to modern science. The implication was staggering. Humanity wasn't just observing an ancient rock. It was staring at something that had witnessed the birth of the cosmos and somehow survived everything since. A cosmic message as more data poured in from the Tianwen-1 Orbiter, the narrative around 3I Atlas began to shift. What once seemed like a silent ancient relic was now being re-examined as something far more profound. A cosmic messenger, a fragment of the universe's first light. Its molecular fingerprints told a story written not in ink or code, but in the ashes of stars that lived and died before the Milky Way was even fully formed. Researchers studying its isotopic spectra noticed something extraordinary. Patterns of metallicity and elemental decay identical to those theorized from population 3 stars, the very first generation of stars born after the Big Bang. These stars, enormous and short-lived, were responsible for seeding the universe with the elements needed for life, and yet, until now, no physical remnant of their existence had ever been found. 3I Atlas appeared to change that. The object wasn't merely composed of early stellar material. It seemed to preserve the chemical memory of those primordial reactions. Within its layers, the ratios of hydrogen to helium, the absence of certain heavier elements, and the faint traces of ultra-rare isotopes painted a portrait of the cosmic dawn, the moment when the universe transitioned from darkness into light. Theorists began proposing bold ideas. Perhaps 3I Atlas wasn't just a stray interstellar rock, but a vessel of stellar heritage, matter ejected during the death throes of a first-generation star, frozen in time and flung across intergalactic space. If true, this meant the object had traveled for billions of years, untouched, until our solar system's gravity finally pulled it into view. For astrophysicists, this discovery bridged the unimaginable. The same universe that gave birth to the first stars now delivered a message from that era, a physical artifact of creation itself. Its existence challenged not only our understanding of cosmic evolution, but also the philosophical boundaries of what it means to communicate across epochs of time. I-Atlas wasn't just older than the sun, it was a witness to the beginning. And as instruments continued to scan its surface, one unsettling thought began to take hold. What if it wasn't just carrying the story of the first stars, but a purpose they left behind? Hidden patterns. When the first enhanced images of 3I Atlas were processed through advanced AI reconstruction systems, what emerged sent ripples through the global scientific community. What had once appeared as random surface irregularities now displayed structured anomalies, precise geometric patterns etched across the comet's frozen crust. They weren't symmetrical in a naturally occurring way. Instead, they hinted at intentional design, the kind of alignment that nature rarely creates by chance. The Tianwen-1 team, joined by data scientists from NASA and ESA, fed the raw visuals into a suite of machine learning models trained to detect non-random features. The algorithms responded instantly, mapping linear ridges, angular formations, and repeating fractal segments embedded within the object's outer layer. Each pattern appeared connected, forming an intricate network resembling data encoding or signal geometry. At first, skeptics dismissed the discovery as pareidolia, the human tendency to perceive order in chaos. But further analysis told a different story. The distribution of these anomalies matched no known geological or astrophysical process. Even after accounting for lighting distortion, pixel noise, and image compression, the structures persisted, sharp, mathematical, deliberate. When researchers converted the shapes into numerical data, an even deeper mystery unfolded. The sequences aligned into ratios consistent with prime number progressions and harmonic intervals, mathematical constants that have no direct reason to exist on a random interstellar body. It was as though 3I Atlas carried a coded language, written across its surface in the universal dialect of mathematics. The revelation reignited old debates. Were these patterns evidence of intelligent origin? Or could unknown natural physics produce such precision? AI-driven simulations attempted to replicate the forms under extreme environmental models, yet none could reproduce the exact alignment. Something about 3I Atlas resisted explanation, defying both chaos and coincidence. Across labs and observatories, one phrase began appearing in internal communications. We are looking at architecture, not geology. The discovery didn't just deepen the mystery, and it reframed it. If the patterns were artificial, then 3I Atlas wasn't simply a relic from the birth of the stars. It was a message, one etched into the oldest matter in existence, now drifting within reach of human eyes for the first time. Global scientific response. When Tianwen-1's findings reached international research networks, the world's leading space agencies found themselves staring into the same unsettling truth. The object orbiting near Mars wasn't just ancient. It predated the sun itself. What began as a localized Chinese discovery quickly spiraled into the most urgent global scientific collaboration since the detection of gravitational waves. At NASA's Jet Propulsion Laboratory, specialists pored over raw telemetry, cross-referencing isotope readings against cosmic evolution models. The numbers refused to fit. The ratios of oxygen-17 and neon-22 suggested formation within the first billion years after the Big Bang, a time when the solar system didn't yet exist. "This isn't debris from our neighborhood," one analyst whispered. "It's from before the neighborhood was built." Across the Atlantic, the European Space Agency held emergency sessions. Their spectrographic data revealed reflective mineral compositions that had never been cataloged in any known comet, asteroid, or interstellar visitor. Some believed the object was a fragment of a dead star's core, encapsulated in unknown compounds. Others weren't so sure. The symmetry in its structure seemed too deliberate, too organized to be a mere product of cosmic chaos. Meanwhile, at CNSA's National Space Science Center, researchers debated the philosophical weight of their own discovery. Lead physicist Dr. Zhou Liang cautioned his peers, "If 3I Atlas truly formed before our sun, we are looking at matter untouched since the dawn of creation. But if its structure is non-natural, then we are not studying the past, we are being studied by it." The comment, though off-record, spread rapidly through scientific circles and ignited quiet panic. For the first time, NASA, ESA, and CNSA agreed to share full datasets under a joint task force. Every new spectral line, every image was dissected in real time across continents. The question shifted from what is it to who made it. Outside the labs, the world held its breath. News anchors framed it as a relic older than the sun. Social media called it the messenger before time. But within the agencies, one thought echoed louder than all. If this object was designed, then something out there has been building since before Earth theoretical shockwaves. The discovery of 3I Atlas sent a tremor through the foundations of modern science. What began as a simple analysis of isotopic data had spiraled into something far more profound, a direct challenge to the story humanity had long told itself about the origins of the cosmos. If the object truly predated the sun, then it was a fragment from an era before Earth existed, before the planets had even formed. It was a messenger from the universe's infancy, a survivor of creation itself. Astrophysicists scrambled to understand how such an object could have endured the cataclysms of time. The isotope ratios, impossibly ancient and unaltered, suggested formation near one of the first supernovae. Yet its geometry, precise, almost deliberate, hinted at something beyond mere natural formation. Theoretical physicists debated whether it was a remnant of pre-galactic chemistry or a construct born from processes unknown to human science. In academic circles, a quiet revolution began. Old models of cosmic evolution faltered under the weight of new data. Some proposed the existence of pre-universal material, remnants of an older reality that had seeded this one. Others whispered of intelligence, entities capable of manipulating matter long before stars ever burned. NASA's lead cosmologist called it a mirror held up to creation, while a CERN researcher privately admitted, "We may be seeing proof that our universe isn't the first." Theories of cyclic cosmology, quantum echo universes, and cosmic recursion flooded the scientific press. For the first time in decades, science no longer had clear answers, only awe. And as the world's telescopes turned once more toward the drifting enigma near Mars, one truth grew undeniable. 3I Atlas wasn't just rewriting astronomy. It was rewriting existence itself. The silent witness. In the end, 3I Atlas drifted on, silent, indifferent, and eternal. Its gleaming surface, scarred by eons, reflected not only sunlight, but the story of everything that had ever been. It carried within its atoms the memory of the first stars, the ashes of ancient galaxies, and perhaps the whisper of something greater, something that had watched creation unfold long before the sun was born. As humanity gazed upon it through the eyes of satellites and telescopes, a quiet realization settled over the scientific world. This was more than discovery, it was communion. For the first time, we weren't just observing the universe. We were staring into its past, into a fragment that had seen it all. It was a witness to time itself, unchanged through the chaos of birth, destruction, and rebirth. The questions it raised could not be answered by equations alone. Why did it survive? What message did its structure hold, if any? Was it coincidence or cosmic intent that brought it near enough for us to see?